Hello and welcome to the section 3.3 lecture today for Algebra 1 Part 1. Today we're going to be looking at solving two-step equations. So we're going to use the tactics that we came up with yesterday, actually the last couple days, and in one-step equations, and we're going to elevate that to a look at some two-step equations. Let's just jump right in and get started. So the top thing I want us to remember are the inverse operations. If I look at addition, what's its inverse? Subtraction. So for addition, we have subtraction. For subtraction, we have addition. For multiplication, we have division. And for division, we have multiplication. Now, for equations that involve two or more steps, we want to apply inverse operations in the reverse order. So if I have something that I have an equation, let's throw an easy one up here. Let's go 2x plus 3 is equal to 13. The first thing I do is that I really look at this one side of the equation. So let me get a little blocker up here so I can just block out something really quick. That didn't do it. That's great. Sorry about that. Okay. So I'm going to block out this side of this equation just for a second. I'm not really going to worry about it. What I'm going to do is I'm going to look at this other side and say, all right, let's say I knew what x was. Let's say x is 10. I don't know that x is 10, but let's just pretend for a second that instead of x, we have 10 here. All right, now knowing what x is, I get an order of operations. I would multiply, and then I would add. So I want to undo those things in the reverse order. I want to start off by subtracting 3 on both sides. And then I'm going to divide by 2. And so the way that I look at that is I ask myself, okay, what's happening to x? And I'm going to write that in the order that I would deal with it. So happening to x. So first it would be multiplied by 2. Multiplied by 2. And then I would take that result and I would add 3. So what I want to do, once I know that this is an equation now, and I have this 13 over here, I want to undo those things in the reverse order. So I'm going to start off with the last step, and I'm going to undo it. Subtract 3. And then to undo multiplying by 2, I'm going to divide by 2. All right, so if I do that, no sense in not doing that in this example, I'd have 2x equals 10, and then dividing by 2 would give me that x is equal to 5. Okay, so a lot of times you'll find me today, I'm going to write down the operations that are happening to x, and then thinking about the reverse order to undo those. So let's take a look at these. Again, if I knew what x was, this one's kind of similar to what we just had. If I knew what x was, I would divide it by 2 and then add 3. So I'm just going to make a note of that. Divide by 2 and then add 3. So I want to undo those in the reverse order. I want to subtract 3 and then multiply by 2. So I'm going to subtract 3 on both sides. And we have x over 2 is equal to 16. And then I'm going to multiply by 2 because that's what I said I was going to do. So I go through that work and it gets me to where I want to be. The beauty with equations is that you can always check your answer, right? I can think of, and I don't even have to, some people say, well, you got to go through the steps. You got to check it, put it in for x, and write all this and do all this and make sure that you get 19. I don't think that you have to do it explicitly like this. A lot of times I just think about it and I say, okay, well, 32 divided by 2, that's 16, and 16 plus 3 is 19. So I would be good. Okay, I've checked it. I've checked it mentally. And if I happen to have a calculator, it doesn't hurt too much just to plug that number into a calculator and kind of do it on there one step at a time and get to your final answer. Okay. On this next one, what's happening to x? Well, if I knew what it was, I would divide it by 2.5, and then I would add 3.2. So I'm going to undo those in the reverse order. So I'm going to subtract the 3.2, and then I'm going to multiply by 2.5. So let's go ahead and do that. Subtract 3.2. So when I do that, I'm going to be left with x over 2.5 is equal to, what's that, 7, oh wait, I'm subtracting, sorry. 1.4? Yeah, 1.4. And now I want to do what I said I would do, and that's multiply by 2.5, multiply by 2.5. I'll probably grab a calculator for that one. So we get x is equal to 1.4 times 2.5. Sorry that you can't see that. I'll bring that over for now. And we get 3.5 for x. And there we go. Okay, let's look at the next one. What's happening to x? Well, if I knew what it was, I would multiply it by 3. And then add 5. I want to undo those in the reverse order. I'm going to subtract 5 and then divide by 3. So let's go ahead and do that. Subtract 5 on both sides. We get 3x is equal to negative 15, and divide by 3 to get x is equal to negative 5. There we go. Just go ahead and pause the video and do this one, and then we'll talk about these other two. Hopefully you had a chance to do that. This one equation is similar to the ones that we've already done, so I don't feel too bad in having you give it a shot. Again, if I knew what n was, I would divide by 2, and then I would add 9. I'm going to undo those in the reverse order. So I'm picking the inverse operations. So we're going to subtract 9 from both sides. And if you're the kind of person that does like to put that line through the equal sign, that's okay. I'd like for us to eventually move away from that because that just kind of muddies things up a little bit, as you can see here. It's an n, not a very good n, but it's thinking about other stuff, I guess. And over 2, I'm going to multiply by 2, and we get that 6 is equal to n. Okay. Now for these ones, they're a little bit different, okay? But I'm going to approach them the same way. So if I knew what g was, because of these parentheses, and these parentheses don't have to be here, anytime you have multiple things in a fraction like this or in a division problem, it's implied that that numerator has to be dealt with first before you divide. So if I knew what g was, I would add it to negative 3. Another way to think of that is I would subtract 3 from g, and then I would divide by 10. Okay, now I want to undo those in the reverse order. I'm going to multiply by 10, and then I'll undo that subtracting 3 by adding 3. Let's go ahead and give it a shot. Multiply by 10 on both sides. That 10 cancels that 10, and we don't have a fraction anymore. And I'm not even going to write those parentheses because we don't need them. Get negative 30 over there, and I'm going to add 3. And so G is going to be equal to negative 27. Not too bad. Again, if I knew what W was, I would have to do this part up here first before I divided. So if I knew what it was, I would subtract 1 and then divide by 7. So I am going to multiply by 7 and then add 1. Multiply by 7. Those 7's cancel. 1 times 7 is 7, and I'll add 1. And we get W is equal to 8. Let's go ahead and turn the page, see what we have for us on the back side. So over here it says to combine like terms and then solve. So what we want to do is we want to look at the side, well, we want to look at both sides of the equation and make sure that they're as simple as they can be. Okay, so when I look at the left side of this equation, everything's good. All right, it's just a 12. And when I look at the right side, I've got a little more involved. I have 2 terms with x's in them. And I want to combine those first before I try to solve this. So I'm going to get 12 is equal to 2 minus 5, which is negative 3x. Now I can attempt to solve it. What's happening to x? It's being multiplied by negative 3. And that's all, so I'm just going to divide by negative 3, and we get negative 4. In simplifying this side of this equation, I've got a 2j and a negative 4j, and then a 10. So the 10's good by itself. There's nothing to combine with that. But over here, I've got a little bit more work to do. 2 and negative 4 is going to be negative 2j plus 10 is equal to 12. And if you want to keep writing the things that we've written before, that'd be okay. What happens to j? It gets multiplied by negative 2 and then added 10. So multiply negative 2, add 10, undo those in the reverse order. So we'll subtract 10. Negative 2j is equal to 2, and divide by negative 2. So we get j is equal to negative 1. Let's look at this one. I've got my 2x here, and then I've got a negative 14 and a positive 4. I should combine those first. So we've got a 2x that's going to hang out by itself, and combining those gives me negative 10 equals 10. If I look at what's happening to x, it's being multiplied by 2 and then subtracted by 10. So I'll add 10 first. Oh boy, I get a feeling for what this answer is going to be. Just another 10. Now I have to divide by 2 and then get that x is equal to 10. A lot of 10s in that problem. Okay. On this next one, I've got a single p and then a positive 2 and a negative 6. So I'm going to combine the positive 2 and negative 6 first. We'll say p minus 4. And this is just a one-step equation to add 4 on both sides. And we get negative 3 equals p. Next one, I got a couple b's that I'm going to combine first. Negative 6 and negative 4 is negative 10b. And then when I divide by negative 10, looks like I'm going to get 0. And on this last one here, I've got, I should bump over, I've got a v, positive 1, and a positive 3v. Notice I'm not dealing with the other side because the other side on all these has been pretty simple. So I do need to do a little combining here. I've got 1v and 3v, so that's 4v plus 1 equals negative 3. Subtract 1 on both sides, and we have 4v equals negative 4. Divide by 4, we get v is equal to negative 1. And that's not too bad. Let's go ahead and go with some application practice here. This one's asking us to write and then solve an equation that is described. The number one important word in verbal mathematics is sometimes the smallest. It's the word is. That is always going to mean my equal sign. Okay, so this says that negative 1 is 8 more than, it's going to mean plus, 3 times a number. Well, I pretty much wrote the equation there. Don't have to really decode that anymore. Now what's happening to n? It's being multiplied by 3 and then added to 8. Undo those in the reverse order. Minus 8, divide by 3. Let's do that. Minus 8 on both sides, we get negative 9 equals 3n, and divide by 3. Giving us n is equal to negative 3. And there we go. All right, make sure you write down any questions you have over on the left side. I hope you got something out of today. Otherwise, have a great day, and we will see you in class.